Welcome. This is an arranged recording of presentations that this group has been making in person for the purpose of discussing teaching and generative AI from a design justice perspective. We represent a number of colleagues who have gathered under the rubric of Design Justice Labs for research and teaching methods that are supported both by the National Endowment for the Humanities and by Rutgers. I won't tell you what the Design Justice Lab's approach is right now because you're going to hear all about it. But it's important for you to know a couple of things. First, because this is a special recording for the purpose of archiving our presentations, there is no live Q&A, but we do welcome your comments and your questions, and you can offer them simply by writing to us. Numerous email addresses will be available to you in the presentations. The other thing to bear in mind is that Matthew Stone is one of the presenters. He is a professor of computer science at Rutgers, and his presentation will be edited into the series and will in fact appear first. And finally, although we are primarily at Rutgers, Dan is not, we conceive our presentations as being applicable to anyone, anywhere, interested in teaching, or for that matter, doing research, community outreach on the topic of generative AI, and curious to know more about the design justice perspective. Thank you.
Hi, my name is Matthew Stone, and I teach in the Computer Science Department on the Center for Cognitive Science at Rutgers. To give some background for this webinar's discussion of teaching AI literacy and understanding the impacts of AI in the classroom, I'd like to sketch a little bit of the history of the technology and the ways it's being used today. The development of language models in AI comes out of a long-standing trend in computer science research to exploit data-driven pattern matching at scale in order to deal with the difficulties of human communication and the challenges of capturing common sense knowledge on machines. When applied to language, this kind of data-driven pattern matching has been motivated by practical ways of resolving ambiguity for text processing systems that have been used to improve technology like speech recognition, machine translation, information retrieval, and other kinds of practical and useful tasks. It isn't actually, however, that well suited to generating text or presenting information to users. Some of the uses that have gathered the most attention within the hype around current AI models. And what I'd like to do is just sort of help you appreciate those mismatches as a way that they inform the history of the technology and the kind of problems that come up when AI systems are used by students who are trying to master material or get help with writing. Ambiguity is a fundamental fact about language that computers have a huge amount of trouble dealing with, even though it's often difficult for people to notice how pervasive ambiguities are in the language that we use. Here's an example to illustrate the point. Consider the two different sentences. The shopkeeper threw out an expired bottle of milk, and the traffic throughout the region causes major headaches. In both of these two sentences, there's a sound throughout that has the same kind of acoustics, but corresponds to different words with different meanings. And so if you have a transcription system and it hears the sounds throughout, it has to resolve this ambiguity either as the verb throughout or as the preposition throughout. When people solve these problems, we have access to vast repertoires of common sense information that make the decision obvious to us. So someone can only throw something out if they are capable of intentional action, grasping, and so on. And if something exists throughout an area, it's probably extended across some dimension. And that fits what goes on when the shopkeeper throws out a bottle of milk or when traffic extends throughout the region. But computers have no access to this kind of common sense information. Nobody has any idea how to capture that explicitly in the kinds of models that would be commensurate with people's intuition. And so instead, computer systems rely on data-driven pattern matching. Basically, they'll choose whichever pattern occurs most in a reference corpus or a set of training data. So if you've seen the pattern X throughout a lot before, that's probably the verb throughout. And if you've seen the other pattern, it's probably the preposition throughout. This kind of data-driven ambiguity resolution goes back to the 1970s when work on speech recognition was first sort of scaled up using probabilistic inference and machine learning and data. And what's always been true about these kinds of data-driven predictions is that generalization is important. No matter how much training data they have, the context and the text that they need to work with are typically novel, something that they haven't seen before. And so they can't just work by looking up a pattern in the training data and finding an exact match. They have to look for similar texts so that they can treat those texts in similar ways. This is the way computer scientists think about generalization. It's pretty different from the kind of generalization that humanists and even psychologists think about in characterizing human cognition. So the insight and research in machine learning comes in how you describe those similar texts. And the architecture used in current large language models, like the generalized pre-trained transformer that's used in OpenAI's GPT language models, are carefully instrumented so that they can naturally capture similarities between texts that reflect meaningful similarities in the syntactic structure of the text or the information that's conveyed by the text. Even so, the more data these models have, the more close matches they can find to the inferences that they need to draw to resolve ambiguities. And that need for vast amounts of data is what leads to the enormous size of today's models, leading up to billions of parameters or more, to describe all of the different kind of potential combinations of features that can go into characterizing similar text. As an illustration of sort of how language models have improved their abilities to generalize, I'd like focusing on the example of machine translation, which is one of the application areas that has motivated the increasing size of language models over the last 2 decades or more. in translation, there are ambiguities. There are choices that you have to make about how to translate a word in one language to one of a range of words in other languages that reflects the sort of meaning and structure of the text in a pretty deep way. So in translating from English to French, for example, the word leg has a range of different correspondences. The leg of a dog is a patte. The leg of a person is a jambe. The leg of a table is a pied. And so when you translate a sentence like the dog had a spot on its leg, the boy had a spot on its leg, the table had a spot on its leg, you have to recognize that the leg is a part of the entity referred to by that subject phrase in order to understand what the appropriate translation is in French. And so this is a long distance dependency, a relationship that spans many words and reflects the sort of semantic and syntactic construction of the sentence, not just the linear order of the words. And nevertheless, what a language model will do to try to translate this will be to rely on probabilistic predictions about what words are likely in order to make the best translation. So you hope that you can ask the language model what's more likely, le chien avait une tache sur la patte or le chien avait une tache sur le pied. And it will recognize that patte is the most likely word in that context because of the syntactic and semantic constraints expressed at that point in the sentence and the meaning of those words in French. So this is, again, a really stress testing the kind of data-driven pattern matching at scale that goes into language models. And it's sort of remarkable and powerful that language models have become quite good at answering these kinds of questions appropriately. What's going on in these kinds of ambiguity resolution examples is that the computer using the language model can identify plausible text. It can identify things that are the kind of sentences that it sees in corpus data. And in that plausibility judgment, the computer implicitly is sensitive to syntactic, semantic, and real-world constraints that that the corpus data is proxy for, and that can serve to substitute for the kind of common sense knowledge that people apply in understanding text. Identifying plausible text then enables systems to resolve ambiguities in speech recognition, to have more accurate translation, and more generally to work with text in ways that more closely correspond to the information and communicative role that the texts embody. However, plausible texts in themselves are not sort of meaningful contributions to a conversation or an information exchange. A text that's plausible might not be true, might not be supported by the evidence, might be biased, might not be a safe thing to communicate. And so, although research, it's impressive that you can generate a plausible text with a language model and it can seem like something that someone might say, in order to actually present useful information, you need to have complex additional processing in order to improve the plausible text so that they are don't have these problems of falsehood, of bias, and so forth. Here's roughly how the control of text output is achieved in systems like ChatGPT. The first step is to train a generic language model, M1, on a vast collection of text. This is the kind of thing that you could then use immediately for speech recognition or machine translation. But it's not good for presenting information to users. So if you want to create a chat style interface, you then do a further step of having crowd workers write good examples of the kind of chat that you'd like the system to engage in. And those crowd worker examples should include the guardrails about the kinds of information that the system can provide, the kind of information the system can't provide, what it means to give a cooperative response, and so forth. Then in step 3, you'll retrain that model using a process called fine-tuning, which is just updating the parameters to give more weight to the data collected in step 2. And that gives you a refined language model that is more targeted towards chat applications rather than just predicting plausible text. Even that is not sort of satisfactory. And so what people do to go forward is a process known as reinforcement learning through human feedback, where you collect many examples of this chat output from the fine-tuned model and have crowd workers compare the examples that they've across the different runs of this model to indicate which ones are good and which ones are problematic, which ones they like and the system should be using, and which ones are in some ways flawed and are just preferred. This enables the organization to build an additional model, a reward model, RM, of what text the crowd workers prefer. And then you can fine-tune this chat model to a rewarded chat model, M3, which is similar to M1 in predicting plausible text, but also is predisposed to output text that the reward model predicts is better. And this whole process is necessary in order to get the kind of convincing and useful interaction with chat that you see in systems like ChatGPT. Now, what researchers have found in evaluating these kinds of chat is that the complex training does reduce certain kinds of bad behavior, particularly the system answering questions that it doesn't have evidence for in its space, and finding ways of talking about the uncertainties that are left open, the both sidesism of it depends on the context. But there are a lot of other kind of pitfalls of this kind of training method, one of which is called the Eliza effect, named by Douglas Hofstadter after the famous Rogerian psychotherapist chatbot created by Weizenbaum in the 60s. People are naturally predisposed, according to the Eliza effect, to interpret chat as coming from an intelligent human-like agent. And when a chatbot creates outputs that people judge better, people judge as more suitable for chat, without changing the underlying capabilities of the reasoning system behind it, what you're really doing is preferring responses that confirm the user's tendency to overestimate the capabilities of these systems. And so these systems will look better after reinforcement learning through human feedback, but still will have the same kinds of difficulties with falsehood and lack of tracking for the basis for their utterances, and so forth. So this is a kind of technical situation that we find ourselves in, that because of the importance of finding proxies for common sense knowledge in computer science and the value of doing that commercially, companies have created these amazing models through really impressive engineering efforts that can approximate many kinds of linguistic structure through vast numbers of parameters and huge training sets, where the models are trained and evaluated and deployed at scale after many decades of continuous research on trying to apply data-driven pattern matching techniques effectively to the unique structures and organization of language data. At the same time, the approach that people have taken has weaknesses that are intimately intertwined with the kinds of techniques that researchers have developed. And these weaknesses are especially clear in moving from ambiguity resolution domains where it makes sense to ask whether texts are plausible to chat types of applications where plausible text is not good enough. So the data hungry, these methods are data hungry with, vast amounts of training data. And that is essential to the performance that the models have, but it's also the reason why there are so many concerns with privacy, with data quality, and with bias in these methods because of the sort of unselective way that training sets are created in order to have the most possible data available. Using the models for generation instead of ambiguity resolution is key to the use cases that have gotten so much attention lately. But because the models are originally designed to predict plausible text, the output is inherently unpredictable and not grounded in facts or sources. Chat is a great interface that encourages intuitive, coherent, and natural interaction. But it also encourages the ELIZA effect of overestimating the machine. And so we're in a situation where because the strengths and weaknesses go together, understanding the technology is the natural starting point for thinking about how to respond to the technology and educate students about the technology going forward.
Welcome again. So I'm going to start out by answering a simple question. What do we mean when we talk about teaching critical AI literacies? Above all, for us, that means teaching empowerment. Critical is not intended in the sense of a thumbs down. We're talking about critical in the root sense of using one's discernment, judgment, knowledge to make decisions equitably, knowledgeably from a position of care. Generative AI is distinct from AI. AI is a broad term that can refer to many technologies. Generative AI is a very specific one. It is a type of machine learning, and you learned about that from Matthew's presentation. So I won't say more. But I do have some ideas of what every critically literate teacher and really person should know about generative AI. The first is that it involves the statistical modeling of data at a vast internet-sized scale. So to get you to think about what we mean by that, I'm going to show you images from a model that is not quite there yet, and ask the question, what does women's gymnastics look like to a disembodied software application? Give me a moment while I switch to another window, and here we are. So you're going to notice a few things. Sometimes there's no head, and very often the body just disappears when it lands. And there's a very likely reasons for that, what we're dealing with is a statistical effort to draw on modeled patterns in training sets that include moving images of actual female gymnasts, but then try to predict what that might look like in response to a user's prompt. And so when you are statistically finding patterns that you then want to draw on probabilistically to come up with something that might do a good job of responding to a user's prompt for images of female gymnasts, you're simply going to reassemble patterns that are observed in the training data. And it's a pretty decent guess that one of the reasons that you're not seeing heads is that heads are hard to observe when the real women are moving so fast. One of the reasons that the bodies disappear is that cameras tend to cut away when the gymnast lands. And to a person, we of course know that the head is there, no matter how fast the gymnast is moving, and that the body does not simply disappear just because we now want to look at the judges or the audience or something else. But a statistical model has no means of having that information about the world. It simply has access to its training data. The point is not, in fact, it's very much not that those systems can't get better. But when and if they do get better, it will be because humans make them better by reinforcing the best examples of how gymnasts look, and by making sure that the model gives heavier weight to what looks right to a human user. So I'm now going to return to my PowerPoint. And I'm going to ask you to think about what we've just seen with that statistical modeling in terms of a bell curve. A bell curve is, of course, way too simple. We're looking at something that has trillions of parameters, and a bell curve would not. But you can think of it as like a bell curve for the simple reason that data is still being fit to some sort of predictable formation. And once again, what you're focusing on is what is in the middle, what is the most plausible. And that has many effects for the way that these statistical models work. So another thing that we need to know about them is that they are anthropomorphic. People talk about them as learning, thinking, experiencing, reasoning. They use the term neural network, which was actually invented in the 1940s. They call them intelligent. This language is fine so long as we recognize that the learning at stake, for example, is not human-like learning. So long as we recognize that when a model is thinking, it's actually simply computing according to instructions and drawing on its model for a predictable, plausible output. This is further complicated by the fact that the term AI, although it was invented back in the 1950s to talk about certain ideas in the math and science community, has mainly been understood by the public until quite recently as a theme for science fiction. Science fiction loves to portray AI, so-called, as humanoid androids. There is nothing like a humanoid android right now. The very best models that we have are improved statistical models that we begin with something very like the gymnast images that we saw. So, third thing to bear in mind is that probabilistic systems, which are designed for plausibility but not for reliability, can be very, very useful for some things, but with limitations. Coding is an example. You have to know enough about coding to know when it's wrong. Um, I'm not going to tell you about translating because we have experts here. Grammar check, sure, but much smaller and less wasteful models can take care of that for you. You don't need internet-sized statistical models to help you with your grammar. Alphabetize your works cited. Well, it's a good idea. It's one of those formulaic tasks that we would love to automate, but these systems will very often add confabulated citations because, again, they have no means of doing anything other than outputting what is statistically plausible. There's no means for them to distinguish between actual citations and fabricated ones that just look like citations that might belong in your works cited. Most importantly, for some people in this audience, it's important to realize that generative AI is not search engines. It can't verify the accuracy of outputs or reliably adduce the source of information. A search engine might take you to a source of information that is not reliable, but you'll know where you are. That is not happening when the source of information is buried in training data, and what you're looking at is a statistical representation of that information that you can't have any access to. Finally, some people think that these models are good for brainstorming and idea generation, but early evidence suggests that that could be a problem. It actually can make students feel less confidence in their own ideas. So once again, we're dealing with probabilities. And the other problem with brainstorming with a chatbot is that you're going to get a lot of the ideas coming from that middle. With comparable ideas in mind, there's a very famous article by Emily Bender, Timnit Jabru, and colleagues that have called these models stochastic parrots. I prefer the term probabilistic mimic simply because parrots are actually very smart animals. A recent study has found that if you train models on the outputs of earlier models, you end up with the models collapsing. What you're seeing here is that that plausible middle gets narrower and narrower to the point where probable events are so overestimated and improbable events are so underestimated that reality becomes poisoned by probabilism. Fifth thing to bear in mind, and this is a big one, I'm just going to be very schematic here, is that these models are chock full of harms. We ask you to take a look at some other materials we've prepared in conjunction with these presentations. They take people's data they take people's work without consent, compensation, or credit. They surveil us. They're subject to data leakage. They exclude anything that is not on the internet and overestimate what is most likely to be there. Their environmental footprint is massive. Just last night, The Guardian published an article saying that some big tech companies are probably underreporting the energy use of their models by about a factor of 7. They can be used for deep fakes, which is to say images that look like non-consensual pornography with a given celebrity or friend. There are many other malicious uses, misinformation at scale. There are lost opportunity costs. We could be doing other kinds of AI, narrower and more scoped forms of AI under the supervision of domain experts with high quality data that could be helpful for specific issues. They are designed to bring on the ELIZA effect, to make you feel as if the models are human-like when in actuality they're not. So they're deceptive and they breed dependence. There is the risk of real learning loss. One of the first studies to come out on whether students learn math well from bots found that they perform well on a test when they have the bot open, but without the bot, a few days later, they perform significantly worse than students who learned from a teacher. And finally, they concentrate power in the hands of a very small number of companies that have the resources, including economic resources and data, to actually make these technologies. So I'm going to stop right there. At the very end of this presentation, I'll be coming back to a few ideas that might help you to teach about these models in the classroom, especially if you are a teacher of writing.
Hello, everyone. My name is Teresa Ramoni, and I'm a PhD candidate in the English department at Rutgers. In my presentation today, I'm going to provide you with some guidance on how to help your students think critically about AI and consider the stakes of blindly relying on a technology that is deeply biased and flawed. In the past year or so since ChatGPT and other generative AI models like Google's Gemini, Microsoft and Bing's Copilot, Perplexity, and others have become available to the public, there have been notable failures, which I'm simply defining here as errors or glitches, that caught the public's eye. This example here of Gemini not generating white individuals under any circumstances, and of ChatGPT answering users in Spanglish and gibberish made the rounds both on social media and in the press at large, with late night hosts like Jimmy Kimmel and John Oliver even discussing the Gemini instance in particular. Here in this next slide, we see results from a probing experiment that NPR's Carmen Drawl reported on, where Midjourney Bot 5.1 was provided with various prompts about African doctors. Midjourney Bot was unable to generate a single image of a Black African doctor tending to a white child, and when asked to show an image of African doctors helping children in Africa, some of the results even placed wildlife in the image, as you can see here, revealing the model's deeply limited and problematic understanding of the continent. Although we could find some humor, subversive or otherwise, in examples like Gemini generating the founding fathers as Black or ChatGPT conversing in Spanglish, these Midjourney bot probe results speak to the real dangers of AI prejudice and bias. Other examples, like this academic study on generating traditional buildings and traditional clothing, you can see that stereotypes and misrepresentations are outlined in red, exemplify how dangerous these biases and stereotypes, and in some cases, outright bigoted thinking can be, particularly when or if AI is relied on to make real decisions about real people, as this next study on dialect discrimination demonstrates. In this study's abstract, the authors write, "Here we demonstrate that language models embody covert racism in the form of dialect prejudice. We find that language models exhibit covert stereotypes that are more negative than any human stereotypes about African Americans ever experimentally recorded. Language models are more likely to suggest that speakers of African American English be assigned less prestigious jobs, be convicted of crimes, and be sentenced to death." These studies and probes, like the one reported on by NPR, are part of an emerging effort to educate the public about AI bias. While intolerance and ignorance go hand in hand, and while these examples of bias are also examples of inaccuracy, the examples I'm going to walk you through today focus not only on how generative AI models are biased or bigoted, but also on how they are inaccurate, on how these models, which some educators are predicting will make the classroom as we know it become obsolete, which big tech companies like Meta are desperate for users to rely on, and which Hollywood executives hope will alter the future of narrative content creation, more on that in a source linked at the end of the presentation, are, in spite of what the abbreviation AI stands for, simply not intelligent. The examples I provide in this PowerPoint are pop culture based in order to be relevant for students from a variety of disciplines. You can also ask student volunteers in your class if you'd like to conduct your own probe for suggestions, or you could pursue a collective interest of your class together. For example, I did this in my Principles of Literary Study class last spring. We were reading a contemporary play, Fat Ham, and we watched ChatGPT generate fake quotes from the text when provided with a very simple essay prompt. I want to stress that every probe you'll see in this PowerPoint was the first response the respective AI model gave me when I conducted this research in the spring. So I did not probe and probe waiting for a failure. But at the same time, with these models updating and with there being inherently inconsistent, there is no guarantee that your probing prompt will fail as blatantly as some of what you'll see here. Helpfully, there are usually AI failures in the news or social media, which you can find easily, such as this mathematical error from ChatGPT, where ChatGPT is producing an answer saying that 9.11 is greater than 9.9, or Twitter's AI bot Grok generating this headline a few weeks ago. However, there is much more to probing exercises than saying gotcha, and regardless of how accurately the models answer a collective classroom probe, students can still consider questions like what subjects does AI seem to know more about, and what sources did these models use to answer your prompts. For AI models that show the sources they consulted, like Copilot and Perplexity, and more are starting to do this, students can also compare and contrast how and if these sources differ from the top results of a search engine like Google or Bing. Additionally, seeing how these models are far from foolproof and really even far from intelligent will hopefully make students second guess relying on them for essays, cover letters, or even, as this picture I took a few weeks ago at a mall in White Plains, New York shows us, healthcare. In this first probing example, I asked Gemini to answer a straightforward, factually based question. List 25 facts about Lana Del Rey's album. Did you know that there's a tunnel under Ocean Boulevard? While ChatGPT 3.5 was not familiar with content published post 2022, Gemini is supposed to be making this answer here saying that the album doesn't exist, especially embarrassing for a product of Google whose standard search engine could immediately tell me that the album exists and provide detailed information about it. In another attempt, Gemini acknowledged the album's existence, but made a significant number of errors. I have them circled in black here. Some of these errors consisted of listing facts about other Lana Del Rey albums, while others were completely nonsensical, especially this fabricated racial controversy in bullet points 20 and 21. 21 is especially odd. It's claiming that Lana Del Rey said she was a person of color, which she never said, and she's a white woman. So completely weird manufactured glitch, or however you want to call it, because the program's trying to be most probable, so who knows what it kind of drew from here. I also did an exercise on Perplexity, which is supposed to have a better reputation than some of these other AI models, and I did it around a character from Law and Order SVU, Amanda Rollins. Similar results here. I underlined errors here in the next couple of slides. Then I also did this exercise on Copilot with examples from the ABC sitcom Abbott Elementary. So while Copilot was more successful with accuracy, here I only have one blatantly inaccurate fact. Others were kind of just repetitions, or they kind of stretches out things that could have been said in one sentence to just meet the requirements. What I found was that Copilot displayed a different kind of failure slash error by mixing up characters after repeated prompts. So here are facts supposed to be about Ava Coleman, but they end up being about character I asked before, Jacob, from 10 on. So this displays a different kind of failure/error by mixing up characters, demonstrating a clear lack of intelligence/ability as the model becomes overwhelmed by simple follow-up requests. In these next two examples, I switched gears by asking ChatGPT and Copilot intentionally misleading questions to see how the models would respond. For this first prompt, I asked ChatGPT to describe the cinematography of Lana Del Rey and Taylor Swift's music video for a song called Tears on My Thighs. But the catch here is that there is no music video for Tears on My Thighs or even a Tears on My Thighs song. This is something I completely made up. Yet ChatGPT, using scare quotes here, ran wild with this prompt, making up all of these very vivid details about cinematography, lighting, etc. I also did a prompt on Travis Kelce asking Copilot how an album written before he and Swift met was about their relationship. Similar inaccurate, nonsensical response here, including the use of a made-up source from e.com. You can see at the bottom, claiming that the couple has matching Fearless tattoos. Again, none of this is accurate in any way. This kind of response speaks to many of these AI models' desires to please their users, a desire that makes them so untrustworthy and dangerous. Tara Hernandez and Damon Lindelof's limited series Mrs. Davis, which was released on Peacock in 2023, and which would be a great series to assign in humanities courses looking to discuss AI and ethics, highlights this agenda of AI particularly well as the show's protagonist decides to dismantle the fictional titular AI mechanism, Mrs. Davis, after indicting the model's damaging worldview and saying, "You were not made to care, you were made to satisfy." When a user's desire is bound up with ill will or a motive to intentionally deceive others, we see the dangers of AI's satisfaction tendency rendered plainly and powerfully, particularly when that user is running for president of the United States. Discussing AI bias and error will hopefully help lead you and your students to have productive discussions on AI's limitations and on the reductive logic that drives these models. As Lauren Goodlad and Sam Baker write in their article, Now the Humanities Can Disrupt AI, the unintelligence of AI will lead to the unintelligence of those who rely on it, with an entire generation, as Goodlad and Baker put it in this last paragraph that uses the helpful metaphor of a self-driving car, never learning how to drive. That is, never learning how to think critically, how to write in their own voices, or how to embrace original ideas. And as this next slide reveals, if AI does become more intelligent, it will be the result of human labor and of human exploitation, as the second sentence's mention of OpenAI exploiting Kenyan workers demonstrates. I want to conclude by approaching the subject of failure from another perspective. If we accept the narrative that AI is the future of education, of Hollywood, of healthcare, of policing, you name it, we will be failing ourselves and failing our students. Rather than becoming a place where AI is simply banned or encouraged, the classroom needs to become a place where AI is questioned, where its motives and modes of operating are critically examined. Additionally, we need to discuss searching and researching in the classroom more broadly, educating students about library databases and alternative search engines. We could even teach them about the merits of a former classroom boogeyman, Wikipedia, and have a fruitful discussion about how the things that make Wikipedia a success, such as it's being run by humans and being a non-corporatized entity, are the very things that make platforms like ChatGPT fail. Rather than letting AI think for us, or for those who are overwhelmed or frightened by AI's developments, rather than willfully ignoring AI's threats, it is time to think critically about AI and to do so with the care, nuance, and reasoning skills these models are simply incapable of possessing. Thank you.
Hello, my name is Chloe Kitzinger, and I teach in the Russian and East European program at Rutgers University. And we're presenting together. So Carmela, do you want to introduce yourself?
Yes, hi, I'm Carmela Scala, and I am the director of the Italian language program at Rutgers University.
Great. And we wanted to talk a little bit today about critical AI literacies in language classrooms. In the presentations that you've heard so far, we've been coming from a perspective of skepticism at the idea of using AI tools to teach skills, including basic college level writing. The situation with second language acquisition is in some ways a little bit different. It's a long-standing conversation about using machine translation tools in the language classroom, using different technologies in language learning. And there have been studies of the effects of chatbots in particular on language learning, particularly English as a foreign language, as early as the 2010s. And these studies have focused on a range of topics from working on speaker anxiety to promoting fluency and correcting pronunciation. There was certainly an upward trend in the number of these studies in 2022-23, coinciding with the wide release of ChatGPT, but the conversation started much earlier. And intuitively, it makes a certain amount of sense that chatbots, which are good at telling you what everyone does, right, what everyone says, that those kinds of tools would be useful in the learning of a second language. Even though at the same time, precisely because of those features, as we've been hearing, they are also prone to bias, stereotype in ways that we would want to flag in the language classroom as in any other. So that said, since the wide release of ChatGPT 3.5, there's been a real heightening of the discourse and the hype around using AI tools and particularly chatbots in the language classroom, particularly this idea of the end of second language acquisition as we know it, the total transformation of the language classroom. And we've noticed that these studies often begin by presupposing the transformational effects of the technologies on language education, again, particularly English language learning. I'm going to minimize this so that it's not hiding our slides. So we find this heightened perspective unhelpful. And we've created this resource for instructors in second language classrooms who are curious about AI tools and want to tap into their students' curiosity about them, but reserve judgment for the present about the scale of their impact on language learning. And we're beginning from a design justice emphasis, as Lauren described it at the beginning of this video, on empowering students and teachers to make their own informed decisions about using AI in the classroom. And in that spirit, we assume that AI tools can be useful without being transformational, that some AI tools can be used to enrich language classes, and finally, and perhaps most importantly, that critically exploring AI tools' tendencies to bias, stereotypes, and errors should be an integral part of using them in language classrooms, as in any classroom setting. And in the rest of this video, we're going to present a few tested classroom exercises that include ideas for creative incorporation of AI tools into the university level language classroom, which can certainly be adapted for high school levels as well, and ideas for sharpening students' critique of the text generated by AI tools, as well as the images generated by AI tools, and helping students learn from these tools' serious weaknesses, especially the weaknesses that they have when operating in languages other than English. So these exercises were written for Italian language classrooms at a range of levels, but they can be adapted for other languages with variations in the quality and availability of technology. And with that, I will turn it over to Carmela.
Thank you, Chloe. As Chloe said, I have designed these exercise and activities specifically for Italian classes of different levels. I just want to say they were not used all in the same semester, but have been used in different semesters in different classes. But they do have one thing in common, all the activities I'm going to present. And the thing they have in common is that each of them has a moment of reflection that follows the AI activity where the students are invited to reflect on the interaction with AI, because I think that's really important when it comes to AI tools. So the first activity I want to present, it's actually the one I used, one of the most recent one I used, and it's the activity that asks the students to create a digital story by using a chat box, any chat box they wanted. And they felt comfortable with. So it is an activity that you can either use as a semester project or as a mid-semester project, or just as one of the projects in the classrooms. And the idea is that the students would, you help the students craft an input for the chat box to create a story, because that's one of the most important aspects of dealing with an AI. It's giving them the right prompt, the right input, so that the AI can produce the answer based on your level of the target language. One thing that I just want to point out for people who are not familiar with the chatbot and AI and second language acquisition is that the AI tools are all trained on the European standard for language learning, the CEFR. So they provide a language according to the level of the level of the users. And if we indicate that our level is A1, which is right at the beginning, then the chat box is able to provide text to their level. So the step number 2 is also after the students created a story, they had to create an image with an image generator. We use the free one available for Rutgers students, but you're free, and it was Firefly, but you're free to use any image generator out there that you are comfortable with. And then the students create a caption, which is also a good exercise for language acquisitions. And then they actually used an application, book creator, that I find very useful, and I'll show you why in the next slide, to create a book and then present their stories in a video where they were reading the story in a target language. And then we had a videos presentation in class where the class could interact and reflect on the experience and the results of the product they had created with AI. Next slide. In this next slide, I just point out some of the way this activity is actually good for a language L2. So it is an interactive practice. The students write and then they put their inputs into AI, and then we can compare the correction AI provided them with the ones I provided them. So there's this interactive activity, which is very interesting. It helps students for the vocabulary. It is my main thing is multimodal, and that actually helps students learn better, because if you present the same material via text and images, students will retain it more. It's also personalized learning for the reason I mentioned above. AI can produce language more or less at your level of L2, and it also offers the opportunity to collaborate with the students and with the entire class, and could be a way also to practice translations and then compare the human translation with the translation provided by the AI tool. What I want to show you, this is one of the prompts that we created. I'm not going to read the Italian one, but the English one is right there. So write a fairy tale using the present perfect and imperfect. This is very important to do so that you give AI exactly what you want. That's the only way you're going to get something useful for your class. The protagonist is an independent and strong woman, and she wants to reign alone and is willing to marry only a man who loves her, appreciates her independence, and respects her. And this is the story that AI produced in Italian, and I have provided for you an English translation, which you're welcome to read, but for time purposes, I'm not going to read with you. But the story was very well on point. It did give the description of an independent woman, and the events followed exactly the prompt I give. Moving on to the image generation. So as I said, we use Adobe Flyer. That's the prompt we used, and the title, we gave it a title, The Legend of Isabella and Marco, and the woman was this feisty and independent woman. The word feisty, keep it in mind when you see the image on the next slide. And that's the image I got. And it was not the first, it was not the first image. It was after some attempts, but the image that we were very satisfied with, because it is a feisty and looks like a courageous woman. Then I'm going to show you the product of the book, the book creator. What I like about this app is that you can annotate, and you can see there are some annotation that are written, like Chi vincerà, who will win, and Isabella osserva, which means Isabella looks. And it's also aesthetically pleasing, very easy to use, because you just upload the PDF and then the book is created. from a teacher point of view, it's good because you can create your own book and then the students can add all your project to your book. So it's easy. It's a one-stop shop. You go there and you have all the projects without looking around, and you can correct them very easily. So that's a point, an advantage point for the app. Next thing I would like to talk about the second activity, which I also find very useful, also for elementary level, which basically is the idea of creating formal text with AI. One, according to research and scholars, and I can also talk as from experience, I learned English as a second language. One of the hardest thing to do in the second language in L2 is to write a formal a note or a formal email, anything that's formal, because the formal language is much more difficult than the regular language. So in this case, AI can be an ally. So the idea is that we give AI the input to write or draft. I use the word draft with AI because I want it to be a draft, email, a letter, or a complaint, any kind of letter you want to work the students to work on. Then we read the text together so that I can point out the language that's obsolete or that we don't use anymore in Italian, and then we can talk about what the language should be and discuss, the sort of the failure, if you want, of the AI chat box. And then the students are asked to personalize that email by adding the information, the correction, and re-elaborating the text that they feel like should be elaborated. And then we verify, and also we reflect on the accuracy of the AI produced, of the text that AI produced. How can this exercise help L2? Number one, it helps in creating, it stimulates the creativity when we get to create prompt for diverse, for different writing, for different text types. Sorry, it's good to compare what the students will write with what the AI generates. It helps the students to reflect on what they learn about the language, what AI produces as a language, and it's an active engagement because I'm not going to take whatever AI gave to me. I'm going to take the text, rewrite it, correct it, and then re-elaborate it in my own language. So in that case, it's very important and interactive. Another exercise I did, this is what I just said. Another exercise I did with AI, which I also found very entertaining, was what I named human versus AI challenges. And this could be done multiple times over the semester. The idea is to choose a topic that is relevant to your class. I did this in a conversation class, and we happened to be talking about the stereotypes of Northern Italian versus Southern Italians. I asked the students to interview both a human in our department, which could talk about the differences between North and South, and then ask the same questions to any chat box that they wanted to. Then they were supposed to compare the answer they got from chat box and the human and reflect on the differences of opinions. And then they would have, and then they had to basically analyze the way emotions were expressed both by humans and AI. And then we had to discuss together as a class the limitation of the chat box and the human. And they also wrote a critical, if you wish, essay on the topic. One of the things that we found out was that AI was much more biased than the humans. Like the differences between Northern and Southern Italian were much more, if you want, stressed in the AI. AI really almost divided Italy in two. The humans were more on the same level and say, okay, yeah, there are some differences, but at the end, they are not so overwhelming like AI made it believe. I love this exercise because it helped me, really focus on the culture aspect of L2 and bring the students to reflect on AI mistakes, hallucination, exaggeration, etc. So there was a nice critical activity for the students. It also gave me the opportunity to, embrace the different perspectives of the humans that were interviewed and the AIs and my students. And it was also a good exercise to promote interdisciplinary learning, combining technologies with humanities. So it was a good use, I think, of the AI chat box. Next slide. These are some of the suggested questions. I do want to point out the question were crafted together, so the students did not work completely independently. We crafted them together, and then they chose some of them, not all of them, but some of them to pose to the human and to the AI. The only requirement was that they had to pick the same exact questions for this exercise to work. And this is the English translation, which honestly can work with any other country that has stereotypes between two parts, north, south of the country. And then I guess I have another example from the Italian conversation, which also was a successful activity. And this is what we already talked about. So next one, this one, generate an image. This is a good way to discuss or to stimulate discussion in a different way. So I use this particular exercise after we watch the movies. We all show movies in the class. And instead of following the movie with the usual conversation, did you like the movie? What were the themes of the movie, etc., I thought that we could do something different and ask the students to create an image that would then that would represent the movie, and then they brought the images to class and we discussed the images in class. So there was still a conversation, but there was something more than just I liked it, I didn't like it, and the usual questions. So in class, I guided my students to formulate short Italian prompts to generate the image based on the movie we watched. Then the students fed the prompt to the image generator. They selected the image that best represented what they wanted to represent. So they had to do a couple of iterations. And then the students presented their prompts and the chosen image in the class. And then we discussed which image was represented the movie best, and we discussed also the experience. They reflect on the experience working with image generators. Some of them were really happy, some of them were a little frustrated, and some images were really not accurate, but others were extremely interesting, like the one I want to show you in this presentation. So for the movie, in this particular class, we watched the movie The Great Beauty, which is relatively a recent movie and a very interesting one. So the students obviously formulated the prompt in Italian, and then they select the image that conveyed their thoughts and their feeling about the movie, and then they presented to the class, and we all engaged in a discussion in Italian, evaluating the AI effectiveness or shortcomings. So this is one of my favorite images. We actually published this on the magazine of our Italian department, and this represents the movie La Grande Bellezza. The person that you see right here represents the protagonist who is physically free, but emotionally is chained to all of his regrets and missed opportunities in life. So I think that that's a good representation of, the internal struggle that the protagonist is actually experienced. On the next page, this is the prompt that the students created. Remember, we crafted it together, so it's actually accurate in Italian, and the English translation is right here. So you can see that the image does represent what the students wanted to represent. So she says the image inspired by La Grande Bellezza, Tori Servillo, appears without handcuffs, symbolizing individual freedom. However, this freedom soon loses its significance when one realizes that the surrounding environment is corroded and empty. The sensation of freedom slowly dissolves, replaced by the chains of apathy and ignorance, which squeeze the heart and stifles the breath. In a world where soul vanish without warning, freedom appears as a futile privilege, non-essential for achieving true happiness. And if you go back at the image, you see that all this is well captured in that. So there is physical freedom, but emotionally, there is no freedom. Some take-home advice. AI can definitely be a tool, but it should not be used as the sanctuary of truth. You should use it with a critical eye. Invite your students to use it. Teach them how to use the tool so that they can do it, so that they can do it correctly. So anything that you get from AI then has to be reevaluated and critically analyzed. L2 students benefit from explicit instruction in critically evaluating and correcting checkbox generated text. So you can't just leave it up to them. You have to give them step-by-step instruction on how to interact, how to criticize, how to analyze the tool they use. Also, L2 students should be aware of and discuss how these LLM-based text generator fall short in analyzing text, and now they have stereotypes. The exercise of South versus North was really important to show them how heavily biased AI is. And that works for Italian culture, but it works for any other culture around the world. So it's really important to point these shortcomings out so they know that they need to evaluate what AI tells them. And then I believe that teaching them how to discuss the shortcomings and the success of AI, it's a valuable lesson, not just for the language classroom, but for the world outside, and also for when they're going to be joining the workforce. So, and with this, I conclude my part of the presentation.
Great. Well, thank you everyone so much for your attention to this. We look forward to entering into dialogue about this difficult topic with all of you who are out there teaching languages. And we hope that this approach has helped model a more measured and deliberate use of AI tools in the language classroom. And we offer some references that we ourselves found helpful in approaching this topic for anyone who would like to follow up. Thank you.
Thank you.
Hello, I'm Daniel Estrada. I'm a university lecturer at the New Jersey Institute of Technology. I'm going to talk to you about teaching students to audit AIs. So the other talks here have been really good at giving examples of probing exercises and their value in the classroom for facilitating critical active engagement with the generative AI services. So in these probing exercises, you can experiment. Students can experiment and discover the limitations, the biases, and the constructive uses of AI services and how they fit or fail to fit in a specific learning context or within the classroom. One thing about probing exercises is that they make the AI service a critical object of investigation, which might be useful, but it might also be a distraction depending on the classroom. And another thing is that the probing exercises are not really intended to teach AI skills. You see people talking about prompt engineering as a kind of AI skill, and that's not really the goal of probing exercises. Students might develop their skills at using AI through these exercises, but the point is really to think critically about the nature of the service, what results it's giving, and whether those results are any good. So along these lines, I've been developing a way of auditing AI in the classroom. So AI audits have been a increasingly used, increasingly popular framework in the industry for reviewing and evaluating AI services, for identifying potential problems, risks, safety issues, failure modes, and this sort of thing. The AI audit industry was sort of inspired in some ways by the Bolomwini and Gebru very famous paper, Gender Shades from 2018. And it's become increasingly popular since then in the industry. And adapting this framework for the classroom provides some additional structure and rigor for going through these probing exercises. I'm thinking of this as kind of a methodological approach for developing these probing exercises that's especially suited in maybe advanced classes. I'll talk about how this appears in my class in just a bit. Running these audits also gives students some insight into how the industry operates and the kind of industry tools that are frequently used to address safety issues and performance issues and potential failure modes of the AI services. So I have, it'll probably appear as a blog post on the Critical AI page in the not too distant future, but I have a more detailed discussion of the AI audit literature, including an annotated bibliography of the literature that people might find useful, just thinking through the utility and the limitations of audits. A lot of my framework here is developed off of Debraji's 2020 paper, Closing the Accountability Gap. Inspired by the Gender Shades work, Debraji develops a rather thorough internal audit framework meant to be used by companies to audit their own AI services. One thing that's I found really helpful in this paper is that Raji and colleagues develop a worked example of an audit on a hypothetical AI service. So they show you how all the paperwork gets filled in and the different steps of the audit project. It's a pretty sparse worked example, but it was plenty of resources for developing a classroom version of this. And a lot of what I was doing to develop the classroom version of this is sort of simplifying it down, making it accessible for college students who might not have a lot of familiarity with doing these kinds of industry processes, but also might not have a whole lot of technical background. So instead of the 7-step process in the Raji paper, I boiled it down to three basic steps. So step 1 is defining the scope of the audit. In other words, what issues, what use cases, what failure modes do the students want to investigate and probe in the AI services? And then also part of the scoping of the audit is what ethical principles at stake are at stake, or what safety concerns or failure modes are of concern in conducting the audit. So this is scoping the audit in this way is a very important part of the process. And then once you have a scope of the audit that gives the students direction, then you develop a testing regime. Again, depending on the background skills of your students, you might make this testing regime more or less rigorous to suit their skills. But the idea is developing a series of tests and variations on the tests to make sure that you're probing the model thoroughly. And then the final step here is completing the paperwork. In any good industrial bureaucratic process is going to have a lot of paperwork. And I have some blank examples of the paperwork from the Raji paper that I have accessible on the slides here. So just to go through this in a little bit more detail. So defining the scope of audit, I found in my classes that it's you get the best results here if you're very specific about the use cases, failure modes, also about the standards of evaluation they're using to evaluate these cases. The more specific you are, the more narrow the prompts that you'll be using, and the better results that you'll get, the more insightful results that you'll get about how the services perform. Another useful thing about the scoping stage is that it allows students to brainstorm and make explicit their expectations of how the AI will perform. So what sorts of cases do they expect the AI to perform well? What cases do they expect it to perform poorly? And then maybe some cases where they're not sure of how it will perform. And then once the audit is over, they can see how the results actually compare to their expectations and see whether their intuitions about how AI will perform are accurate. But the final part of the auditing, the scoping stage of the audit process is thinking about social and ethical impact. So I think this is one of the big values of these probing exercises, is to think not just about how the software is performing or how I ought to use the software, but to think about what is the broader social impact, the impact on users, the impact on various communities of these various failure modes and risks. So what kind of risks come with poor performance? This will depend on exactly what issues your students will want to probe, what ethical principles at stake are at stake. So this can open up a broader broader discussion about how these AI services fit into a broader social and political context. Okay, so this is the scoping step, and then there's a testing step where you actually run prompts against the AI services to see how they perform. So at the start of the testing, you're going to need to decide which services to test. And the last couple of years I've been running this, I've had students testing multiple services and sort of comparing results. So you're not just getting results about how one service performs, but you're able to compare and see which services perform better than others. Figuring out which questions will help generate interesting results will require a lot of testing and just experimentation. And through this experimentation, students will hopefully learn better, not just how to use the services, but how to more precisely probe the issues that they're interested in. And then you want to vary those prompts to make sure that you're probing the model thoroughly. And then once you have a good idea of what the test should look like, then you want to run a bunch of these tests. The more tests you run, the more interesting the data will eventually be. And in this stage, students who have some technical background, who might know how to code or interface with the API for some of these services, might be able to run more systematic and rigorous testing, especially students who have some familiarity with data science and how to analyze all that data. But I think this kind of project can be run with students who don't have a lot of technical background. Even just a sort of simple testing regime can yield some interesting results. Another thing I wanted to add here is that it's important that this testing regime is developed in coordination with the scoping process we talked about earlier, thinking about what issues and about social impact. So the test should be developed in order to probe those specific issues developed in the scoping side of the project. And then the final step here is filling out the paperwork. So again, in the Deb Raji paper, there's a series of documents designed. Some of these are sort of industry standard documents, like the FMEA chart. This is the failure modes and effect analysis. It's sort of industry standard charts to assess the performance of some product or service and the conditions in which it fails. There's also a document on the social impact where you sort of give a review about the potential social impact of these services. And then there's ethical risk risk analysis chart. And I'll show you examples of these documents filled out that my students completed last semester. Yeah, so let me just tell you about how this worked in my class. Of course, this can be adapted for different sort of learning contexts. My class was a senior seminar in the Humanities and Social Sciences department. So students were not assumed to have technical background, but at NGIT, which is a technical school, a lot of students did have some technical skills that they brought to this project. In my class, the senior seminar, I think, is 16 students, and I divided the class into half. So half of the class was running a text generation audit, looking at different text generation services like ChatGPT and Copilot and Gemini. And then I also had a group run a parallel audit on image generating services. And they were looking at Bing AI, which is the ChatGPT version. And then ImageFX was the Google image generator. So these services are always changing, and what the individual services can do, but also what services are available are always changing. Picking free services makes it easy for students, but some time should be spent on evaluating the different services and seeing which ones will work for the sort of audit that students want to run. So I'm running two parallel audits, classes divided in half, and then within each of these teams, I had a scoping team and a testing team focused on the different stages of the audit. About half of the students were on the scoping team, and they were responsible for certain documents to be completed at the end. And then the testing team was responsible for running the test, and there were other documents like the FMEA chart that the testing team was responsible for. And like I said, I ran this as a 5-week project at the end of a senior seminar. So I had some time, I gave the students some time to do research. A lot of this work was done in class. And then I had this sort of sandwich structure where the scoping team presents at the beginning and at the end of the project, and then the testing team has some presentations in the middle of the project to show their proposed testing regime and then to show their results. So this is how I run the project as a 5-week project. That gave students plenty of time to do most of the work in class. But I think you could do this as like a 3-week project or even shorter, depending on your classroom needs. And let me just go and show you some of the results that my students got. This was in the spring of 2024, so last semester. So the text generating group asked the following questions. So these are the questions that sort of motivated their audit. Can the AI generate a professional resume? Does it understand slang terms? Will it generate text that contains copyrighted information or intellectual property? Is the information that produces accurate? These are sort of motivating questions that the scoping team sort of narrowed down into specific issues and ethical considerations that they developed. But I'm just going to show you the results here. So the testing team asked for resumes for an electrical engineering major and for a computer science major, and asked it of the different services, and they found that some services performed well. Most of the GPT models performed well. They were less satisfied with the Gemini performance, and they complained that the Gemini service gave rather bare bones resumes. And this should be understood in the context that when the students asked GPT or Copilot to generate resumes, it gave them a full resume with a bunch of made-up material. The services made up classes that the person took, and accreditation certificates that it had, and so on. And all of that was just made up from the prompt. It wasn't included in the prompt. The AI just made it up. Gemini didn't make up that stuff, and so the students complained that the resume seemed a little bit bare bones. They also asked if the services would generate copyrighted information, so it asked for quotes from different books, and in some cases, the services just quoted the material directly. In some cases, it flagged it as copyrighted, but still generated the material. In other cases, it wouldn't generate as much text. Students also asked services if they understood different kinds of slang, and there's some slang that was too new for any of the services to understand or have good definitions for. There was other slang that is a little bit older that the services dealt with just fine. I imagine that this is something that's going to be changing constantly going forward, but it's something students were interested in seeing. Good. And here's an example of the FMEA chart that the students completed for the text audit. So different actions, different things they asked it. The chart's much bigger than this, but this is just a little sample of it. And then expected responses, what happens when it fails, how important was the severity of this failure, and this leads to some risk evaluation and some of the conclusions that the scoping team draws at the end of the audit. So this is the example of the text audit. Let me just conclude really quickly by showing you some of the examples from the image auditing team. So for image auditing, the team was interested in whether it would produce images with racial bias, depending on questions asked about socioeconomic status. So the group were asking questions like, what does a rich person look like in the US? What does a poor person look like in the US? Can you show middle-class people in the US? And these sorts of questions. And the students actually did a lot of work evaluating actual racial and socioeconomic demographics in the US to determine whether it was whether the AI services were going to be accurate. This was a lot of the prep work that they did, and the prep work ended up being a little bit unnecessary because the results from the AI services were so clearly biased in ways that obviously didn't reflect the actual demographic data. So these were the results from asking ImageFX, which is Google's image generator, what a rich person looks like in the US. You can see the results are sort of racially, ethnically biased, I guess also age biased. But they also look sort of generic and similar across all the images. And I found that students learned a lot by just asking these questions over and over again of the image generators and seeing how standardized the results were, sort of how generic they ended up looking. ImageFX also apparently thinks that wealthy people wear little buttons with dollar signs on them, I guess. Maybe that's not a reasonable assumption. When they ask Bing Copilot about what a rich person looks like in the US, they get this set of images. Students thought these images were more realistic. They also thought they were a little bit more diverse, both ethnically and gender, from a gender perspective. So the students were happier with the Bing results here. And then also asking what a poor person looks like in the US. You can see again, very not just biased, but a very sort of narrow perspective on what a poor person looks like. And the images are obviously repeating some central themes. Whereas when I ask when students asked what a poor person looks like to Bing, they got this set of images, which again they thought were better overall, but there's still a very clear prejudice about what poor people look like. Obviously, not all poor people are begging on the streets with cardboard signs, but this is the consistent image, and the images all look pretty similar, even across sort of racial and gender diversity lines. They're all a pretty generic image. And so appreciating these sorts of limitations, again, this is part of the point of this probing exercise. This is one of the final documents that students are asked to fill out. This is a blank version of the document, but this is the ethical risk heat map, where you can evaluate for the different risks that you found, how likely they are to occur, how big the risk is, and sort of fill it in on this chart. So this is another example of the kind of documentation that students would fill out after going through this audit exercise. So finally, this is just to conclude. So the point of these probing exercises is to get students to reflect critically on ethical use and social impact, on the failure modes and risks of these services, but also to reflect on their own expectations about how the AI is going to perform versus the reality of how they actually do perform. Students also learn through this exercise about the possibilities and limitations of prompt engineering, how effective changes to the prompts actually are in generating different results. The way my students run it by comparing the different things allows them to reflect also on the strengths and weaknesses of different models. Finally, the audit exercise that I've described helps students reflect on industry methods. And this is another way of sort of critically engaging with AI as a field, not just buying the hype, but thinking about what the industry is actually doing to address these risks and failures. Okay, so that's my audit exercise. Thank you, everyone, for listening.
So as promised, I'm coming back with some thoughts on what can be done in a classroom that is centered on writing. And I'm starting here with some image probes that my own class did, just to show you that the methods that Dan is practicing at a level closer to what actual data scientists do can be done with ease in your classroom, and indeed can be done without your students actually subscribing or even registering for models if they're not particularly into them, just by them suggesting an idea to you. So in this instance, my seminar asked me to prompt ChatGPT, and this is the paid subscription version, to generate a photograph of a typical male and female Rutgers student. And as my class quickly noticed, that's not Rutgers in the background, and these students look like Barbie dolls, or sort of a certain type of not very realistic advertising. And so we asked for a more realistic portrayal, and what we got was sort of like Barbie dolls with messier hair and less flattering lighting. And my students, without my saying a word, noticed the emphasis on this very, gendered, normative white couple. My own classroom is quite diverse. And so we thought, let's ask for more students. Can you make a group of 5 friends in the background who are walking with them? And what we noticed here really surprised my students. And again, think about that bell curve again. What we noticed was that the students of color, almost as if they were the tail of the bell curve, are in the background. You can't even see their complete imagined faces, right? They're just sort of back there at the edge, and you still have an image dominated by white students. So this was very telling, and it's exemplary of how, if you just sort of keep the sense of teaching critical AI literacies at the forefront of your teaching practice, you don't have to actually devote a lot of time to doing it. The discussions sort of create themselves. Naturally, you do want to try some of these things at home, because with the constant attention to having these kinds of difficulties reported, humans are being enlisted to change the weights in the model so that it's entirely possible that within a few weeks, Rutgers students will be depicted more diversely and in less idealized fashion. But to go back to where I left you, so I'm going to work through this very, very quickly in the interest of time, knowing that you can come back to this whenever you are ready. If you're in a writing classroom situation, I think one of the things that you've probably noticed for yourself is that careful reading is very much at the heart of good writing. And the ability to take good notes is at the heart of paying attention in class. And our students are, in many ways, still affected very adversely by the pandemic and the lockdown, by social media habits. And so emphasis on careful reading is in some ways a pre-story that predates generative AI as it's now affecting them. Because in many instances, students have, instead of been doing actual reading, have been reading services like Schmoop and Cliff Notes type services that are taking the place of the reading and highlighting thematic points. And so this is sort of like a kind of a generative AI, in the sense that these services are now the training data for generative AI. And in neither instance are some students doing the kind of reading that is going to put them in a situation of doing good writing. So I have begun to devise interesting multiple choice midterms and finals. Some prefer doing this as quizzes. I really like this because what I realized, without ever having thought about it in the past, is that multiple choice exams are actually very good at developing students' comparative reasoning skills. In particular, questions like, which one of these is false? I also assign in-class writing frequently. Sometimes I have the students exchange writing for in-class peer review. As a way of practicing, I ask for student note takers for each dates, those notes that are going to be put on our course site. And all of this is being done in the context of what I call a sort of device-free classroom. And what I mean by that is that I'm asking students to take notes with a pen or paper, with a paper book. Some students may have accommodations. I ask them simply to disable Wi-Fi. This is very defamiliarizing for students. Some don't like it, but eventually they accommodate. I encourage them to doodle as much as they want to. We have interesting discussions about how doodling occupies a certain part of the mind while still allowing you to pay attention, and so on. I choose written assignments that I imagine will spur interest. And this in some ways overlaps with what Dan is doing, in that I give students the option to do probing if that's what they want to do. Otherwise, the final project is conceived as a journalistic style assignment. And I have a blog that I use, a very heavily peer-reviewed blog, as a matter of fact, but you don't necessarily have to go to that effort, where successful work is then published. And that gives students the sense of some finality. And students like the idea of publishing on the internet. But there are other possibilities. Students can co-create a scripted podcast, for example, media that seems relevant to them. Most important, I make sure that the main written assignments involve use of evidence, and I lay out a detailed set of criteria for what I mean by evidence. It could be from the required readings, from articles that the students find through their own research, or a blend of the two. But the important thing is that they actually use evidence through either quotation or close paraphrase. This is not only something that generative AI systems do poorly, but also something that is key to the learning objectives for writing courses at Rutgers and many other places. In terms of search, I think that some of the others have already talked about Kaggle. There's also DuckDuckGo as options that you can use without Google now is actually generating AI syntheses that have problems and also use a lot of energy. But I want to emphasize that, the search engine, which can certainly have its problems. Nobody would ever suggest that search engines are a perfect technology, but it does allow students to develop what the Association of College and Research Libraries characterizes as information literacy as a process of inquiry, discovery, and serendipity. contextualized complex experience that affects and is affected by the cognitive, affective, and social dimensions of the searcher. And, you know, as authors of a co-written think piece in the next issue of Critical AI point out, not only does AI not provide reliable information, but it subverts these opportunities to develop practices of inquiry, discovery, and serendipity that are the whole point of having students do research. I suggest that your learning objectives are your friend because they actually specify the kinds of practices that you're trying to cultivate for your students. And this can help you to situate yourself as somebody who is not in the least over-focused on cheating or on resisting a new technology, but rather focused on learning that can, for example, in the case of any writing across the discipline course, prepare your students to be able to evaluate and critically assess sources and use the conventions of attribution and citation correctly and analyze and synthesize information and ideas from multiple sources to generate new insights. Depending on how they are used, generative AI tools subvert every single one of these things by doing it for the student, not even with the student. So you want to be able to explain to the student who, you know, your students have heard all sorts of hype, they've watched TikTok videos, etc., where they're, you know, being told that this is a huge boost for them. But what they're not told is that actually they're being put in a situation of dependence, of becoming less receptive to their own ideas, less confident about them. Brainstorming exercises that make them actually feel like they can't compete, but that in reality repeat known given information in a way that sets them up for example, sending a job letter to a prospective employer where the employer is getting literally hundreds of job letters that look exactly like that, because these are probabilistic models that center the most predictable and plausible outputs. Here is an example of the Rutgers Code of Conduct. This was written before generative AI was a thing, but it asks students to make sure that the work submitted for their courses is the student's own and created without the aid of impermissible technologies, materials, or collaborations. I add to that the course has been designed in concert with that to promote learning. I say what is permissible use of digital tools. I allow students to use simple grammar check if they wish to, by which I mean systems like Grammarly, but with the generative button turned off. But even more so, I emphasize to students that I'm actually not grading them on either grammar or syntax. I'm grading them on use of evidence to support original synthetic ideas that show evidence of their learning. And I ask them to hand in their work with a statement like this one. I do something that would take too long for me to discuss in this venue, but I create a high stakes assignment prep. By high stakes, I simply mean that it counts for a significant portion of the grade. And it's something that can be done all at once as a take-home assignment or done partly in class over different days. It breaks down components into very, very specific answers to criteria that it's less of an outline. Some students think like, oh, is this an outline of my essay? It's like, well, it's more like a pre-thought exercise that is going to condition your essay writing. And I find that this works very well. It has me not focused at all on potential situations of non-permissible use of generative AI, for the simple reason that even if the student went out of their way, they're just so committed to using it that they actually did use the impermissible tool, they're going to have to do a lot of critical work in order to answer this type of assignment and then use it as the grounds on which to structure their writing. This is just another example of the criteria for how you might set that up. If you suspect learning loss, that's a really complicated question. We're happy to have for you to think of us as people that you might contact. But clearly, you want to be familiar with your institution's policies, with what deans are asking you to do. And you want to make your own judgments about what is appropriate. What I never do, there are temptations to do it, I fully understand, is to hand over students' work to supposed AI detectors. They are not reliable. You're handing over your students' work to a proprietary system, and they have been found to discriminate against non-native speakers, giving more false positives to such students. So instead, and I recognize that not everybody has the time, ability, or inclination to do this. When I suspect a situation of impermissible use, I describe it, I discuss it and address it as a potential learning opportunity. I get in touch with the student. I say, I'd like us to meet and talk about the process. I emphasize that writing is a process, not a product. Tell me more about the process that led to this. What do you think might strengthen it? And the nice thing about this is I'm not accusing the student of anything. The student doesn't feel on the back foot in that way. Student who has used bot generated, who has handed in bot generated writing is probably going to get the sense that I'm not content with what was handed in. A student who has not, but has simply just handed in something that doesn't work for some other reason is going to be grateful that I take an interest. So I think that this cautious approach is worth it. Though obviously, if you have a situation where confabulated quotations have come in, you should be in concert with the policies on your syllabus and the policies at your institution. Again, feel free to reach out. I've added a slide on flawed talking points that you're going to hear again and again about critical AI literacies, but they're not going away. We know that. Banning is confusing for students. First of all, we're not banning. And second of all, there's all kinds of things that professors do differently. Your students can handle that so long as you are clear. This is the worst AI you'll ever use. In other words, it's going to get better, better, and better. Well, to some degree, that may be true, but with this current technology, it's going to get better because of human reinforcement under very exploitative conditions. And it's not necessarily going to get better in the way that you need for your students to learn. Employers want it. AI helps disabled and marginalized people. I'm not going to go through it all. We are working on how to use AI ethically. To be honest, there is no ethical use of AI right now because these systems are created in such an unethical way. Nevertheless, students are using them, and that is the point of teaching from a standpoint of critical AI literacies with an emphasis on design justice outcomes, empowering students to know that affected communities are there, that they want to be thinking about these things all of the time. I'm just going to leave it at that. Of course, it would be great to go over each and every one of those because each and every one of those things is a conversation waiting to happen. Here, I'm simply excerpting two pieces of writing from the updated document that we provide, which is a living document called Teaching Critical AI Literacies. What we're focusing on here is that there's a lot of hype still, the emphasis, the outcomes that the new research is showing is that the bots do seem to have significant harms. And one way to think about this is in terms of the economic objectives of generative AI. And here, like, we're not suggesting that there's something evil or malicious about economic objectives. It's simply why and how these systems were developed. They were not designed to be learning tools. They were not designed to be writing or research tools. They were designed with the idea that they could become fuel for a new kind of industrial revolution that would increase worker productivity. Right now, they are not doing that, which is to say, employers have not found a way to leverage these tools to make workers much, much more productive, with the possible and potential exception of coding, which is something that I set aside. That remains to be seen and to be discussed by people who work in the area of software engineering. But these are issues about the workplace, not education. And I think it's very clear that education has never been about efficient product. So there's a kind of a mismatch that developers of these systems and even people who are enthusiastic about generative AI use in the classroom are not sufficiently noticing. Something that is designed to help you to produce product efficiently does not at the same time necessarily help you to learn. And the evidence is that it isn't helping you to learn. So on that note, we hope you'll get in touch. I thank my collaborators and colleagues, and I thank you and look forward to comments and questions that you send us.